Okay class, so we are going to talk about graphs of functions today. So we're going to review domain and range, but we're going to focus on increasing, decreasing, and constant, max and min, even and odd, and graphing of piecewise functions. So we are going to start off with domain, and we are going to use what's called interval notation, which is the notation that we've been using. So for the domain is the x values, and I see that the x starts at x equals -1, and it goes all the way over, and I see it here, but this arrow tells me it's going to continue going up forever and right forever. So using an inequality, I know that x is bigger than -1, not equal to, because it's an open circle at x equals -1, and it goes all the way to infinity, which can also be written as x is bigger than -1 and less than infinity. But these are inequality notation. We're going to use interval notation. So the bigger than symbol would be equivalent to the round bracket -1 comma infinity with also a round bracket. So we're going to be using interval notation, not inequality notation. So range is the y values. The y values start at y equals 1 and goes up to infinity. So in inequality, we would write y is bigger than 1, not equal to, because it's not filled in, but if it was filled in, it would include it. So round bracket from 1 all the way up to infinity, and that would be interval notation. So we're not using inequality, we're going to be using interval notation. Intervals for increasing and decreasing. So the intervals, these are along the x values, so along the x-axis. Okay, so to look at it where it's increasing, I can highlight it. It's increasing here, kind of like positive slopes. It's increasing here, and then it's increasing all the way up to infinity. So to write the intervals, it's the intervals along the x-axis. So it goes from -1 to 1, and again from 1, 2, 3, 4 to 6, and again the x value of 8 all the way up to infinity. So the intervals along the x-axis are from -1 to 1, it's increasing, so -1 to 1, comma, it's also increasing here, which is between x values 4 and 6, and then again from 8 to infinity. Oops, 8 to infinity. Okay, intervals where it is decreasing, so to highlight those, it's where it has roughly a negative slope, so it's decreasing here and here. So we can write those intervals, and again, it's the intervals along the x-axis, so between 1 and 2, it's decreasing, so from 1 to 2, and then again from 6 to 8, it is decreasing. Now technically on these endpoints, it's not increasing or decreasing, so it's a round bracket because it doesn't include those, because at the point 1, it's neither increasing or decreasing because it's just a particular point. So it's an open interval. Okay, so constant is the place where it's not increasing or decreasing. It's just a horizontal line. So at the endpoints, technically it is constant at that point. But your book is using a term called open intervals, so it is constant between 2 and 4. So we're going to go ahead and be consistent with the book with round brackets around 2 or 4. For relative min and max, those are x, y coordinates, and if you're going to do this on your calculator, you do need to do calc max or calc min. So these values are relative maximums, and this value would be a relative min. Okay, so if you had to do this on your calculator, you do calc max, calc min. Okay, so there are some relative maxes at the x coordinate y, x coordinate 1 and y coordinate 1, 2, 3, 4, 5, 6, 7, and then 9. So there's a max at 1, 9, and also at 1, 7, and 6, 9, and then the min is at 8, 5. Okay, so those are just x, y coordinates. Okay. So even and odd functions. An even function is symmetric across the y-axis. So you have, this is your axis of symmetry, it's across the y-axis. It's not any graph that's symmetric vertically, it's specifically symmetric to the y-axis. odd functions, any function is odd, is symmetric to the origin. So for example, if I take my function and I reflect it across the x-axis, and then I reflect it across the y-axis. Okay, so it has two reflections, which is essentially reflection across the origin, across the y-axis and across the x-axis. You could go here, and then you could go down if you need it. Okay, so that is even and odd. So for this, it says find a second point on the graph f if you have a point 5, comma, -1. So we have a point 5, comma, 1, -1 that we're going to plot. And I want it to be even. So if it's even, it's symmetric across the y-axis. So if it's symmetric across the y-axis, if this is my graph, if it's something, and this is a point, I know that same point, but over here on the other side of the y-axis. So this point is -5, -1. Okay, so now I know that is symmetric. If it's odd, your point 5, comma, -1 is symmetric across the origin, which means you have to reflect it across the x-axis and the y-axis. And you could do it in any order. You reflect it across the y-axis and then the x-axis, but in the end, it's -5, comma, +1. And so those points, if they were functions, make it even or odd function. Okay, so finally we are going to graph piecewise functions. So the expectation is that you already know how to graph a line. So this first equation here, this is the equation of a line. So this is 1/2 x plus 3. Okay, so x over 2 is 1/2 x. So to graph it, you know that the slope is 1/2 and the y-intercept is 3. So I'm going to graph the y-intercept of 3 and the slope of 1/2. It means up 1, right 2. Down 1, left 2, down 1, left 2. So this follows the equation of a line. You should, of course, use a ruler. And we're only going to graph it when x is less than or equal to 2. So here's my x value of 2. So I'm only going to graph it to the left of 2. So I'm not going to continue going right. I'm going to go left. And it's less than or equal to 2. So it's a closed circle here. And I'm only going to graph it to the left of x equals 2. So I have that line. Then I'm going to have this. This is the line y equals -1. So it's a line y equals -1. And lines where y equals -1 are horizontal lines. So it's a horizontal line going through y equals -1. So it would be this entire line here. But we're only going to graph that line when x is bigger than 2. So here's where x equals 2. So I'm only going to graph the line when x is bigger than 2. So it's going to be an open circle at 2 because it's strictly bigger than, not bigger than or equal to, and then to the right. Okay, so if the inequality symbols were kind of switched, where this was strictly less than to begin with, then it would be an open circle. If it was bigger than or equal to, it would be a filled in circle. Okay, so the 2 value tells me we're on the x-axis and said only look at it to the left, and this says only look at it to the right. Okay, and I of course want values on my axes. Okay, so that is all. That is graphing piecewise functions. So it's called a piecewise function because it has 2 particular pieces. So to start off, we're only going to be graphing piecewise functions with linear functions, but as we progress, we will do piecewise functions with any of these sort of graphs. So I hope you have a great evening, and I'll see you in class.